Right, this is question 9C from your recent mock paper. Again, I suggest that when you're observing or watching these videos, you have your mock paper in front of you. If you didn't get this question right, I suggest you have a go at it before you look at my ways and methods of trying to teach you good examination technique and what you should be already aware of at this point. Now, first things first, we've got a reaction with ammonia over here. Okay, and there are a couple of things that we should know about ammonia as well. Number one, if we were to draw out the ammonium structure, we would know that ammonia is in group 5, NH3. That means that it's got 5 electrons in its outer shell, and therefore 3 of those electrons are being used up by the covalent bonds with the hydrogen, and you've got a pair or a lone pair of electrons there. Now, whenever you have a lone pair of electrons, we should be aware that the lone pair of electrons can act as a nucleophile, meaning that it is a electron pair donor, or a base, meaning that it is a proton acceptor. Now, the question is actually asking you for something very specific again. Again, you'll recognize the pattern. It's asking you for a name and an outline. That means you need to name the mechanism and also draw what the mechanism or the mechanism itself. I would start off this reaction by drawing out the molecule itself, or the molecule that you're reacting the ammonia with. Notice that there is no negative charge on the ammonia over here because those lone pair of electrons itself indicate that they are negative here. Now, as soon as we've drawn out that molecule, maybe it might occur to you that the bromine and carbon-bromine bond there is electronegative. Bromine is more electronegative, so we could indicate that that has a partial negative charge, and the carbon there has a partial positive charge there. Now, considering the ammonia is going to be attacking, it's not going to be attacking on any of these carbon-hydrogen bonds. The only bond it could attack on is this carbon over here, or the slightly positive carbon. So we should be able to draw our mechanism and draw the line, or showing a full-headed arrow from in between the electrons going onto the carbon there. Now, this is indicating that a dative covalent, so to speak, bond has formed there. Now we know that carbon cannot have 5 bonds as indicated at this stage, therefore as the bromine is more electronegative, it's going to be taking the electron that it was sharing with the carbon itself from here. So we can draw an arrow indicating that that has happened. Right, at this stage you would have formed this molecule over here, this intermediate. However, there is one significant thing that we need to add. Considering that ammonia likes to form 3 bonds normally, it's used its pair of electrons to form this covalent dative bond. In effect, it's got a proton in here, but this nitrogen needs to be positively charged. If you do not put that positive charge in there, you will lose a mark. Now, this ammonia likes to be stable, and it likes to only form 3 bonds, so we need another method of removing a proton from this area over here. Now, in general, in this nucleophilic substitution reaction, ammonia is considered to be in excess. I've already mentioned to you that anything with a lone pair of electrons can be considered to be a base. I'm just going to remove that bromide from there for the time being. Therefore, we know that ammonia has a lone pair of electrons and it should be in excess. Therefore, we can, in theory, remove one of these hydrogens here, or that proton there. Remember, a proton is a hydrogen without its electron, so that electron has been left there, and that needs to stabilise this positive charge over here, so we can indicate that that electron has gone back to nitrogen to stabilise that charge there.